Hey everyone, and welcome to our Codeship webinar about how to use containers for continuous integration. I'm Manuel Weiss, I'm the co-founder here at Codeship and our director of marketing. And with me today is Kyle Rames, one of our awesome senior engineers at Codeship. Just a quick look at the agenda. So Kyle's going to talk about why containers are a really good fit for continuous integration. And we'll specifically be looking at two technologies, and those are LXC and Docker. And we'll look at the benefits, but also the issues you might run into with these technologies. And we feel we can tell pretty well about that because we have extensive experiences with both technologies because we're both using them at Codeship. And after comparing LXC and Docker, we'll talk about how we at Codeship are currently using Docker containers and how they help us achieve what we try to do with our CI system. And lastly, Kyle will be talking a little bit about how we see the future of CI, where things could go thanks to the awesome container technology and what we think can all be possible and what we might work towards too. And I just want to mention that throughout Kyle's talk, we will collect questions, and I'll try to answer as many as possible of them in the question panel via text, but we'll also have a dedicated Q&A session after Kyle's presentation, and we'll take the time to answer any questions, should there be any, then. And lastly, I want to say, please be aware that this webinar is being recorded, and I'll happily share the recording with you next week and the slides and useful links. But enough from my side now. Let's get started, and I'm handing over to you, Kyle.
All right, thank you very much, Manny. As Manny said, today we're going to talk a little bit about using containers for continuous integration. And containers actually make an excellent building block for a CI service. They're actually a lightweight form of virtualization that sit inside of a host operating system. They use very little in terms of both memory and CPU overhead. And at the same time, they're isolated. So if I have a build running in one container and you have a build running in another container, we're not going to see each other or interfere with each other. And this is actually particularly important when you start thinking about external services you might need in your tests. So if you're firing up Postgres or Redis, you are going to have your own copy, and your container is going to ensure that you're the only one talking to your instance of Postgres. And what's really awesome is that you're not going to have to do any special configuration of Postgres to do that. You can just use very standard ports. Containers also enforce resource limits. So if my build for some reason has an infinite loop and starts running away with CPU resources, you're not going to have to worry about that impacting your build or the host operating system that our containers are running on. And likewise, if your build has a memory leak and starts sucking up memory, I'm not going to have to worry about the stability of my container or the host operating system. Containers also provide some security, which is very, very important to us here at Codeship, because the day we leak someone's source code is most likely the day that we go out of business, and we actually count on containers to do this for us. And lastly, containers actually provide us with a very consistent build environment. So it's like actually receiving a perfectly provisioned machine every single time that we can run our build on, and when we're done with it, we throw that away. And so what that means is if your tests are very good and very robust and very deterministic, like mine are, that if you run a build today inside of a container, you're going to get this, the same results as running that build tomorrow in that same container. So now that we've talked a little bit about containers, let's actually talk about our first technology. We're going to look at LXC. And LXC actually takes what's known as a very machine-centric approach to containers. And that actually makes more sense if you look at the following diagram. So you can see here that the blue field represents our LXC container, and inside of it we actually have three processes. We have our Postgres, we have our Redis, and then we have our tests that are running. And there's actually a lot of benefits to this. It's a very flexible approach. I can fill up that LXC container with as many processes as I would like. I can install my own software and have my own view into the container. And it's also very automatable, which, as you can imagine, having a CI server or a CI service for that matter, that automatability is a very important issue. So LXC provides a command line which you can use to create and destroy containers. And as awesome as LXC is, it's not without its own issues. The first thing that you're going to have to do if you use LXC is that you're going to have to create an image. So at Codeship, for our classic product, we actually use LXC, and we have to use a program called Packer, and Packer actually creates the image for us. It's going to install that Postgres and that Redis server and whatever else we want into that image. But unfortunately, that image is not going to be super portable. It's only going to work on an operating system or a machine that looks very similar. So if your CI server rather is Red Hat Enterprise and you're trying to run that same environment on your local dev box using VirtualBox and Ubuntu, that image is most likely not going to work for you. And again, the LXC kind of brings this challenge with environmental parity. So that image may or may not work on my developer laptop. So now that we've actually talked a little bit about LXC, let's dive in to Docker. And whereas Docker took a very machine-centric approach to virtualization, Docker takes a very application-centric view. So if you see here in this diagram, you'll notice in the Docker example that we actually now have 3 containers in one process per container. And we also have red lines that are connecting these various processes. And this is a very typical setup for Docker. You typically just want to have one process per container. And this approach actually brings a lot of benefits. First off, because there's this standard one process per container, along with several other kind of Docker best practices, it's much easier to kind of know how your system should look in a Docker environment. And this standardization actually brings a lot of very strong tooling and automation support with it. So Docker has a command line very similar to LXC, which will allow us to create and also kill running containers. But in addition to it, you have things like Docker Compose, which will let you orchestrate creating multiple containers and connecting them, like we saw in our example. It also allows us to use production deployment technologies like Dias or Flynn or Mesos. And the area of tooling right now is just really exploding around Docker. Docker also automatically builds an image. So where we had that issue with LXC, where we had to generate an image using Packer, and we have to do that every time something changes. With Docker, you actually create a Docker file which describes everything that should be running inside of that container. And then when I run that on my CI server that's running Red Hat Enterprise, or when I run that on my local machine, which is using just plain old Ubuntu, Docker's going to go ahead and automatically build that image for me. And because of that, we got a lot of image portability. So now we can start to think about being able to run that same image on our machine and on CI and in staging and in production. And this image portability actually enables us to then distribute these images. And there are actually a lot of repositories that are out there for Docker images. There's Docker Hub, there's Key.io, and you can actually even run your own registry if you'd like. And we actually have an ebook on our site called Host Your Own Private Registry on AWS. So if you do want to have your own container registry, you can do that, and I would encourage you to download that document because it's entirely free. Docker also allows us to have versioning and history. And so when we have an image, we can actually see how it was built, the certain commands and layers that are available. And this is actually particularly interesting when you think about starting to develop with languages that generate build artifacts. Like Java or Go, you can actually have your build process generate a container, then you can push that container up to a registry, and then you can actually deploy that code that was built and tested on your CI server onto your production environment. And again, this Docker kind of enables that environment or parity, which I talked about earlier. Docker also has a lot of momentum. So if we go out and Google LXC, you'll actually see that it has a respectable 400,000 results. This is actually way more than my blog, but it's not quite as much as Docker. Docker has somewhere in the order of 15 million results. And all these searches means that there's a lot of contributions out there. There's a lot of problems that have already been solved. In short, Docker has a very vibrant and growing community. And this actually makes developers and DevOps people alike super happy. And as awesome as Docker is, it's not without its issues. First off, there is a little bit of a high barrier to entry. As I kind of mentioned, there's some standards on how you do it, as opposed to LXC's approach where you just throw everything into one container. There's also a very robust tool chain. So it takes a while to kind of get up to speed on those and how to use those properly. But once you do, you'll be able to kind of move a lot faster and a lot farther with Docker than you would with technology like LXC. There's also kind of less visibility. So if you go back to that diagram where we had our 3 containers, you can see that it's very difficult at times to know what is going on with each container. Especially if you think about firing up a database and then firing up your tests. Your tests have to know when your database is up and ready and running. So there's some challenges there, and even really challenges just trying to kind of get everything connected. So we talked a little bit about LXC and a little bit about Docker. Now I want to actually talk about how Codeship is using Docker today, because I think this is very relevant in how you might kind of design or approach a CI system using Docker. So we're going to take our diagram that we saw earlier with Docker, and we're going to see how to kind of translate that from just a plain old diagram to actually reality. We're going to do that with a tool called Jet. Jet is actually a tool that Codeship creates. It's free to download, entirely free to use, and this is actually the engine that powers Codeship. So again, this is the diagram we're going to do, but I thought I'd like to make it a little bit more interesting, and I'm going to introduce a fourth container for deploying. And what we're going to do is, if our tests successfully pass, we're going to go ahead and then deploy our code out, so you can kind of realize some continuous integration as well as continuous delivery here. And so to do this, we're going to actually use two different files. We're going to use a Codeship services file, and that's actually going to describe the diagram. And then we're going to use a Codeship steps file, and that's going to describe how to use our containers to run those tests. So we're going to start off by looking at the services file. And this is what services file actually looks like. We tried to adopt and use Docker Compose syntax wherever we possibly can. So if you're actually using Docker today, there's a chance that you'll be able to kind of get some reuse. There are some things that we don't support quite yet in the Docker Compose syntax that we're looking at implementing. There's some things like allowing you to get access to the local machine that we probably won't adopt. And then there's also some directives in there that are specific to Codeship and do things like encrypt credentials for us. So you can see here the blue boxes show the actual containers that we're building from that diagram. And this is actually how we're going to go ahead and then build those containers. So you can see for both tests and deploy, we're going to give it a Docker file, which is going to describe how to actually build that image. And then for Postgres and Redis, we're going to actually go ahead and pull those down from a registry. So you can see here for Redis, we're just going to use the official 2.81 from Docker. And for Postgres, we're going to use a custom created one from the my.org user. And then I also wanted to point out the link section. If you remembered, we had those red arrows that connected our various boxes. We actually do that via the link section. And again, this is very similar and consistent with the Docker Compose syntax. So now that we've actually seen the services file, let's go ahead and take a look at the steps file. So this is our steps file, and it's pretty straightforward. You can see here that we mentioned the services that we want to execute the steps on. In this case, test and then deploy. And these are the corresponding commands. And the way this is set up is that it's going to run serially. So it's going to start off by running bin/unit tests on our tests container, and then bin/runlint, and then bin/acceptance. And that if any of these commands fail along the way, our CI process will exit and say there was an error. But if all those steps deploy, or rather, if all those steps pass, then we'll go ahead and run that deploy command. And we actually have the ability to discriminate which steps are run for for which services. We do that through a tag file. So you can see that we're only going to run this deploy section if we're actually on the master branch. So that was a little bit of Codeship Docker today. Now let's actually talk a little bit about where we see Codeship Docker evolving into the future. So first off, we see that CI should be native. So if you're deploying on Red Hat Enterprise, you should be able to use Red Hat Enterprise on your staging server and also kind of run it locally. And so you can kind of see how Docker enables us to do some of that today. We also see it as being something that's very personal. So you'll see with a lot of like CI services that they'll only have certain versions of MySQL or Postgres or Redis available. We believe that you should actually be able to bring and use whatever software services and libraries you have on your machine. And again, you can kind of see how Docker enables us to do that. We had brought a custom version of MySQL over from that MyOrg and being able to kind of build our own containers. We also see CI as being something that's instantly available. This is actually something as a developer that I really want. And I think we're making strides, and this is something that the world of cloud and the infinite cloud resources kind of can help us realize. But we're still working on that. And then lastly, we see CI as being something that's intelligent. So if all of a sudden your builds start getting slower, we think that your CI service should be able to kind of alert you that you might have possible performance regression. Or if you were testing in a certain manner and there's a much better way, we kind of would love to see a future where CI would be able to kind of help you write better tests. So with that, I'm going to turn it back over to Manny.